Welcome to everyone. Welcome to everyone. Today our topic of discussion is 12th chemistry chapter 2 solutions. So what is the definition of a solution? A solution is a homogeneous mixture of two or more substances whose composition can be varied within certain limits. So this is the definition of the solution. What is a homogeneous mixture? Homogeneous mixture means that its composition and properties are uniform throughout the mixture. So that is the definition of a homogeneous mixture. You can pause the video as well as you can write what is written on the board. The next terms of definition are solvent. The component present in the larger quantity is called the solvent, and solute is the component present in the smaller quantity. These two terms, solute and solvent, they are relative to each other. And solute plus solvent is nothing but solution. So that's the idea here. So we are seeing the next part of the lecture. So this is a series of notes on solutions. This is the part 1. And the fourth question is write the characteristics of a solution. So it is a solvent which determines the physical state in which the solution exists. A solution is a single phase system and it will not allow a beam of light to scatter. The particles of solute in the solution cannot be seen with the naked eye. So that's the next. Cannot be seen with the naked eye. I think I went a little bit ahead. So I'll explain all these things. Next one is a solution is stable and the solute from the solution cannot be separated by the filtration process. The solute particles in the solution do not settle down. So these are the characteristics of a solution. So let's go to the next slide. So give the classification of solutions based on the solvent. The solution is of the following types. Aqueous solution, when a solute is dissolved in water, it is called aqueous solution. If at all the solvent is water, that means the solvent. If at all the solvent, if it is water, then you would say that the solution is aqueous solution. Okay. So the next slide is the non-aqueous solution. So when a solute is dissolved in a solvent other than water, it is known as non-aqueous solution. The example is iodine in alcohol. It is also called tincture of iodine. And aqueous solution, you can think of like ethanol in water or salt water. That's an aqueous solution. Okay. So let's move ahead. So next one is a binary solution. What is a binary solution? A solution which contains two components is called a binary solution. So for example, salt plus water, that is a salt solution. Ternary solution, the solution which contains three components is called a ternary solution. So the next, let's come to the next slide. So the ternary solution can be of two types. One is two solvents with one solute or one solvent with two solutes. So these are the two types you can have. And now the next part is the classification of solutions based upon the physical state of the components. So that is, there are three such types will come. So the first type is solid solutions. The type of solution is solid solution. The solid solution in turn will have the three types. So that is a solute based upon the solute. The solvent is same, it's a solid, and the solute will keep changing. So that's what the idea you need to have. And the gas in solid, the example is hydrogen dissolved in palladium. And liquid in solid, that is the mercury dissolved in sodium, forming an amalgam. Amalgam is an alloy of mercury with a metal, sodium amalgam, zinc amalgam, like this. The amalgams are made whenever mercury reacts with metals, it forms something called an amalgam. And solid in solid, there are alloys. For example, bronze. So bronze is an alloy of zinc and copper. The next one is type of solution, that is liquid solutions are the next kind. So gas in liquid, liquid in liquid, and solid in liquid. Gas in liquid is oxygen in water, that is H2O. When oxygen is dissolved in water, that is a gas in liquid type. And a carbon dioxide in water, which is soda, which we know very well. So these two are the examples of gas in liquid. And liquid in liquid is like beverages, all alcoholic beverages. They are like ethanol in water. Such beverages like coffee, even coffee, if you mix decoction in milk, okay, something like that. So it is like mixer, it's like a liquid in liquid. Okay. So I'm just telling an example. Strictly speaking, that's not the actual example. So it is like you can think of like orange juice mixed in water. So such kind of things, beverages. Okay, they are all the examples of liquid and liquid. And when you have solid and liquid, that's a pretty known example, which is salt in water. So let's go to the next slide. And gas in gas, that is gaseous solutions are of three types. Once again, gas in gas, liquid in gas, and solid in gas. Those are called gaseous solutions. You see, the solvent part will not change, it's the solute part which keeps changing. So gas in gas is air is a mixture of nitrogen, oxygen, and etc. Some other gases like moisture, argon. You have different gases like carbon dioxide, so and so. And liquid in gas is carbon tetrachloride mixed in nitrogen gas, and you can have humidity in air. That is a case of liquid in gas. Humidity means the water vapor which is present in air. Okay. And solid in gas, that is camphor in nitrogen gas, and humidity in air. So these are the examples what you have. Let's go to the next slide. So dilute solutions, relatively very small quantity of solute present in the solvent. So that is called a dilute solution. Concentrated solution means relatively very large quantity of solute present in the solvent. So next, let's go to the next slide. Define concentration. The concentration is the amount of solute present in the given quantity of solution. So that is called concentration. Define mass percent. Mass percent is mass of a component per 100 grams of solution. That's what is called mass percent. And a formula for calculating mass percent of a component is given by this. Mass percent of a component is given by mass of a component in the solution divided by total mass of the solution multiplied by 100. So this is the formula. So let's go for a binary solution which is containing A and B. A is a solvent and B is a solute. So WA is the mass of the solvent and WB is the mass of the solute. Then mass percentage of B is given by WB, that is a mass of the component B, that is a solute B, divided by the total mass WA plus WB multiplied by 100. So this is how we calculate. Now this is the problem 1 I am showing you. So there is a 10 grams of glucose dissolved in 90 grams of water. Find the mass percentage of glucose. So this is the question. So weight of solvent, that is water. Water is a solvent. So I'll write it as WA, which is 90 grams. That is given in the question. The 90 grams is the amount of water. And the weight of solute is the glucose, is the solute. So that is 10 grams. And I'll call it as WB. So mass percentage of glucose is given by WB divided by WA plus WB. So multiplied by 100. So just plug in the number. So 10 grams divided by 10 plus 90 multiplied by 100. So the next one is 10 by 100 multiplied by 100. 90 plus 10 is 100. So you get 10%. That is called 10 weight percent or 10 mass percent. You can say it as 10 weight and mass. You can interchange. No issues about that. So 10 mass percent of glucose. So that is how one can say 10 grams is, you can say weight also, no problem, because we are all these experiments are conducted on the earth. So you can consider it as the very much you can consider it as the weight percent. The next one is the solution formed is 10 weight percent of glucose, or you can write 10 mass percent of glucose. Okay, 10 mass percent of glucose. So what does it mean? A total of 100 grams of solution is formed. So when you add up the 90 grams of water, so how it is coming up, 90 grams of water is mixed with 10 grams of glucose. So that's how they merge together to form the 100 grams of total solution. That's what the total mass of the solution is. So let's go to the next slide here. So the mass percentage is also written as weight by weight. So it is weight to weight percent. and generally it is used in the industrial chemical applications. And the commercial bleaching, for example, the commercial bleaching powder solution contains 3.62 mass percentage of sodium hypochlorite in water. So this is the industrial application what we have with the mass percent. So let us take a problem. This is the last part of the lecture. So calculate mass percentage of benzene C6H6 in carbon tetrachloride CCl4 if 22 grams of benzene is dissolved in 122 grams of CCl4. This is the question which is given. And let us see the weight of C6H6, that is 22 grams, and the weight of CCl4, that is 22 grams. Mass of C6H6 is 22 grams, and mass of CCl4 is 122 grams. And what is the total mass of solution? That is weight of benzene plus weight of CCl4. So which works out to be 122 plus 22, which is 144 grams. So the next part is like this. So mass percentage of benzene is the next calculation. That is mass of benzene divided by mass of the solution multiplied by 100. So mass of benzene is 22 grams over here, divided by 144 grams. Actually, these grams will get cancelled out. So 15.28%. You see, it has no units. Okay, the mass percentage is not having any units. This is a very important point which you need to know. It does not carry any kind of units over here. And now because it is weight by weight, right? So the grams and grams are getting cancelled. This is what you had to know. The next part is that mass percentage of CCl4 is what we are going to calculate later. So that's nothing but mass of CCl4 divided by mass of the solution. That is actually the total mass of the solution. That is 122 grams divided by 144 grams. The grams and grams will get cancelled. 122 by 144 multiplied by 100. That works out to be 84.72. Or you can take something like 100 minus what is the weight percentage of the benzene, that is 15.28. You can subtract 100 minus 15.28. You get this one. Check it up. So this is how one can calculate. If you have a binary system, if you have the mass percent of A plus mass percent of B, that happens to be always 100. If you have a 100%, so that happens to be 100%. So if you know this trick, you can just solve the problem just like that. So if you calculate one mass percent, the other mass percent can be easily calculated by just subtracting from 100. Okay, so other component can be calculated by just subtracting from 100. This is what you get. Okay, so that's it. That's it. That's the end of the video, and this much is the first lecture on the solutions, chapter 2, 12th chemistry. Yeah, thank you all. Thanks for watching the video.